Hey guys, so in this video I'm going to discuss example 5.19. In the previous videos I discussed example 5.17 and 5.18. Along with that I explained you guys what is gamma integral and how it works. So in this video we are going to use gamma integral, some portion of it. So it's better if you go to the previous video and check out what is gamma integral and then come back to this video. So let's just start now. Right. See, I'm going to discuss 2 or 3 more examples or questions related to single variable continuous distributions, and then I'm going to move on to joint continuous distributions in probably the next video or the video after that, right? So let me just write the question. Example 5.19. 5.19. So this says that fx, the PDF is fx y naught e to the power minus b x minus a, where x lies between a and infinity and b is greater than 0, right? B is greater than 0. Where a, b and y naught are constants. So we need to show that y naught is equal to b equals to 1 upon sigma and a is equal to m minus sigma, where m and sigma are respectively the mean and the standard deviation. Also show that beta 1 is 4 and beta 2 is 9. So let me just write the formulas. I don't remember the formulas. Let me just write the formula for beta 1. The formula for beta 1 was the third moment with respect to the mean, the square of that, upon the second moment with respect to the mean and the cube of that. Beta 2 was the fourth moment with respect to the mean divided by the second moment, the square of the second moment with respect to the mean. The square of the second moment with respect to the mean. Let me just check the formulas. Yes, mu 3 square upon mu 2 cube, and beta 2 is mu 4 upon mu 2 square, right? Also mu 3 is, let me just write the formula for mu 3. Mu 3 is mu 3 dash, the third moment with respect to the origin, minus 3 times the second moment with respect to the origin, first moment with respect to the origin, plus 2 mu dash 1 whole cube. The cube of the first moment with respect to the origin. This is mu 3. Mu 4 is m4 dash minus 4 m3 dash m1 dash plus 6 m2 dash m1 dash whole square minus 3 times m1 dash to the power 4. Minus 3 times m1 dash to the power 4. So m4 dash minus 4 times m3 dash m1 dash plus 6 times m2 dash mu1 dash whole square minus 3 times mu1 dash to the power 4. So also, what is m3? M3 is just the expected value of x minus mu whole cube. M4 is ex minus mu to the power 4, expected value of this. And what is mu2? Mu2 is the variance sigma square, which is equal to ex minus mu whole square, right? Which is equal to ex square minus ex whole square. So let's just find the value of y0 first. The PDF given to me is fx is equal to y0 e to the power minus b x minus a, where x lies between a and infinity. Now how do I find the value of y0? I'll just integrate the PDF over the limits a to infinity, which will give me the value of this integral equal to 1, because this is the area under the curve, right? So my lower limit might be is a, and my upper limit is infinity. So the area under the curve will give me this will be equal to this integral of this whole from a to infinity will be equal to fx dx will be equal to 1, right? So now just applying this formula, a to infinity y0 e to the power minus b x minus a dx, just taking out y0 because it's a constant term. This gives me a to infinity e to the power minus b x minus a dx, which is equal to y0 e, integrating this term gives me y0 bx minus a upon minus b. Wait, let me just write this below. So this is dx, this is dx, so this is equal to y0. Now integrating this term gives me e to the power minus bx minus a upon minus b, and my limits are a to infinity, right? So this gives me y0. Now when I put infinity here, this will become e to the power minus infinity. E to the power minus infinity is 0, so this will give me minus b comes out because it's a constant term, so this gives me 0. And when I substitute a here, this becomes e to the power minus 0 or e to the power 0, which is 1, so this becomes 1. Now minus minus is plus, so this gives me y0 upon b, right? And now we know that this should be equal to 1, right? This integral, the PDF, this should be equal to 1. So y0 upon b is equal to 1. This whole integral should be equal to 1, and the value of this integral is y0 upon b. So y0 upon b is equal to 1. Y0 upon b equals to 1. This shows that y0 is equal to b, right? Now let's find the rth moment. No, wait. Now I need to show you guys. Now I need to show that y0 is equal to b is equal to 1 upon sigma, right? Now we all know that what is sigma. Sigma is equal to root sigma square, right? So for finding this, for finding sigma, we will find sigma square. So sigma square is e to the power x minus mu whole square, or it's equal to e to the power x minus e to the power x square minus e to the power not power ex square, the x square in the expectation operator minus ex whole square. I'm sorry, I was saying e to the power x again and again. This is not exponential term. This is the expectation operator ex square minus ex whole square, or this is equal to m2 dash minus mu1 dash whole square, right? So this is equal to, now for finding sigma square, I need to find ex. I need to find this value. How can I write ex? Can I write the x as ex as ex minus a plus a, right? This is the same thing. So if I just take out a from this expectation operator, I'll be left with e plus ex minus a, right? So therefore my ex is equal to a plus ex minus a, right? Right. So this is a property. This is a property of expectation operator, that a plus by, where y is a random variable, y is rv random variable. This is equal to a plus b ey, right? I am just showing you the property so that you don't get confused. And I just added and subtracted minus a and plus a, so it makes both of these things equal. Right. So now moving on. Now I already have a, right? A is a constant term, so I'll find ex minus a. Ex minus a. Also, I showed you guys. Okay, let's just find the value of ex minus a first, right? So ex minus a is equal to a to infinity x minus a fx dx, right? So I'll be finding the rth moment. So I am finding the rth moment with respect to the point a, which is, I'll be finding ex minus a to the power r, right? When this r is equal to 1, so the first moment with respect to the point a, this is equal to ex minus a to the power 1, which we needed to find. So I'll be substituting it later. First I'm finding the rth moment with respect to point a. So finding ex minus a to the power r gives me x minus a to the power r, now fx dx, right? So this is e minus b x minus a dx, and y naught comes outside because it's a constant term, and y naught was equal to b, so b comes outside. So this gives me from a to infinity, right? Now let x minus a is equal to t. This gives me dx is equal to dt. Also, as x goes to a, t goes to 0. As x goes to infinity, t goes to infinity, right? So just see here, right? When x goes to a minus a, t goes to 0. When x goes to infinity, infinity minus a is equal to infinity, so t goes to infinity. So my limits for t are, or let me write this again, x minus a is t, dx is dt, x goes to a, t which is x minus a, as x goes to a, t which is x minus a goes to 0, x goes to infinity, t which is x minus a goes to infinity, right? This is 0. We have everything now. So finding this gives me, right? So let's just substitute it. So my limits now have changed from a to infinity. It has become 0 to infinity. This is t to the power r e minus bt dt, and b is outside. So this is equal to, let me just remove all of this. Let me just show you guys. So this ex minus a to the power r becomes a to infinity. This was a to infinity, x minus a to the power r, b was outside, constant term, e to the power minus b x minus a dx, and this is equal to, now from this is equal to b, 0 to infinity, t to the power r, x minus a is t, t to the power r, e to the power minus b t dt, right? Now in the previous video I explained you guys what is gamma integral, and the formula for gamma integral is, the form of gamma integral is 0 to infinity. Whenever we have 0 to infinity and any variable x, I am taking x, or let me just take p, I am taking p as the variable here. So p, whenever I have p to the power n minus 1 here and e to the power minus p dp, then I can say that this is equal to gamma p, right? Sorry, gamma n. This is equal to gamma n, which is n minus 1 factorial. And there is one more property which I didn't discuss in the previous video, which is whenever we have the form 0 to infinity p, again same as above, e to the power minus, now I have a constant term b here, right? So for example, I have b here, so minus b bp dp, this gives me gamma n divided by b to the power n, which is equal to n minus 1 factorial upon b to the power n. Now I'll be just showing you guys this, how I'll convert this. So just remember this property, right? So whenever I have this form, this gives me gamma n, which is n minus 1 factorial, and whenever I have another variable or a constant term, sorry, not a variable, a constant term being multiplied in the power of e with the variable p, then I'll be getting gamma n upon b to the power n. Now let's just apply the formula. So we had b, constant term, 0 to infinity t to the power r e to the power minus b t dt, right? So this r and the gamma r, both of these are different. This is just the power, right? This r and this gamma and r are different, right? This signifies gamma integral, right? And this is just the power, right? This is the rth moment. Let me just delete all of this now, right? So this becomes b, and now I can write this as 0 to infinity t, right? So r is equal to n minus 1, n is equal to r plus 1, right? So n minus 1 becomes r plus 1 minus 1, right? So I can write this as r plus 1 minus 1, essentially the same, e to the power minus b, right? Minus bt dt, yes. So this gives me this, the value of this integral is b, constant term. This becomes gamma r plus 1. This is the gamma integral, the variable used to denote gamma integral, and this r is different, r plus 1, right? R plus 1 upon b, which is this b, upon b to the power r plus 1, which, and this b gets cancelled. This gives me gamma. I can also denote this as gamma and bracket r plus 1. These, both of these things are the same, and b gets cancelled. This gives me br, right? So this b and this b gets cancelled, gives me br in the denominator, right? So my power, my value of ex minus a to the power r is gamma r plus 1 upon b to the power r. This and this are the same thing, right? So if I put the bracket and or if I remove the bracket, both of these imply the same thing, right? So gamma r plus 1 upon b to the power r. Now this shows that the value of ex minus 1, now r is equal to 1, right? So gamma r plus 1, so r plus 1 is 1 plus 1, r is 1, so 1 plus 1, so gamma 1 plus 1 divided by b to the power 1, right? See, gamma, now r is 1 plus 1 upon b to the power 1. This implies that we have gamma 2 upon b, and the value of gamma n is equal to n minus 1 factorial. Therefore the value of gamma 2 is 2 minus 1 factorial, which is 1 factorial, and the value of 1 factorial is 1. So we have 1 in the numerator divided by b in the denominator, right? So we have ex minus a, which is equal to 1 upon b. Now we know that ex is equal to ex minus a plus a. Therefore taking out a, using this property, a plus by, where y is a random variable. This gives me a, b, e, y, right? I discussed this just now in the previous slides. So this becomes taking out a, and this gives me e x minus a, right? So this is a property. So this gives me a plus e x minus a. You can also see that the value of b here is 1. This b is different, right? This was just a property. I'm just deleting this so that you guys don't get confused. Or let me just change the variables using the property. So the property says that e c plus dy is equal to c d e y, right? So here my c is equal to my positive a, and my d is equal to 1, my d is equal to 1, and my y is x minus a. My y is x minus a, my d is 1 here, and my c is a, positive a, right? So I'm just removing the 1 here for now. So this gives me my expected value, or my mean, is a plus, and the value of e x minus a is 1 upon b. So my mean is a plus 1 upon b. Now, finding the standard deviation, we need to find the variance, and the value of my variance is sigma square is e x minus mu whole square, where mu is my mean, which is also equal to e x square minus e x whole square. But I am going to use this definition, right? So e x minus mu, and my value of my mu is, or my value of my expected value is, a plus 1 upon b. So mu is just e x minus e x whole square, right? So the value of this is e x minus a plus 1 upon b, and the whole square of this. So this becomes e x minus a minus 1 upon b whole square, which makes this term as, now I need to find the whole square of this. So what I'll be doing is that I'll be dividing this into two terms. So this gives me e x minus a minus 1 upon b whole square, right? So this gives me e x minus a whole square, e x minus a whole square plus 1 upon b square plus, wait, or let me just write the whole properties so that you guys understand. So, and this is plus minus 1 upon b whole square plus 2 x minus a minus 1 upon b, right? So this gives me e x minus a whole square. Now this is 1 upon b square. Let me just put in, this is 1 upon b square, and this is equal to 1 upon b square minus 2x upon b, so multiplying 2x and minus 1 upon b, and this is positive 2a upon b, right? So this negative and negative gives me positive, right? So I'm just now opening the bracket. Now using this property, e is equal to c plus dy gives me c plus dey, right? I'm just opening this, x minus a whole square plus 1 upon b b square minus 2x upon b plus 2a upon b. So opening this gives me, e x minus a whole square plus 1 upon b square, right? Because it's a constant term. Now this gives me 2 upon b, which is d here. So e x plus, now again 2a upon b is a constant term, so just comes outside, right? Now we know the value of this, we don't know the value of this, right? So for finding e, we just found the rth moment, right, with respect to a, and this was equal to r, this was equal to gamma r plus 1 upon b to the power r, right? This r, right? So the value of e x minus a whole square gives me gamma operator 2 plus 1 upon b to the power 2. b to the power 2, right? This makes ex minus a whole square as gamma 3 upon b square. Gamma 3 is 3 minus 1 factorial, which is 2 factorial. 2 factorial upon b square. This is equal to 2 factorial upon b square. Ignore this b. Let me just erase this. 2 factorial upon b, which is 2 upon b square. 2 factorial is equal to 2. 2 upon b square. Therefore, the value of ex minus a whole square is 2 upon b square, right? So now let's just find ex. This was equal to, right? So we were finding this only, right? So we were just finding this, right? This value, right? And this, the value of this was this whole expression, right? This whole expression. Then we opened this up, and we were left with this, right? We were left with this expression. Right? So just evaluating this expression gives me ex minus a whole square plus 1 upon b square minus 2 upon b ex plus 2a upon b. This is equal to ex minus a was equal to 2 upon b square, right? Plus 1 upon b square, this term, minus 2 upon b. Now the value of ex was a plus 1 upon b. I showed you guys in the previous slides. So a plus 1 upon b, right? Let me show you again. You see here. So where is my a plus 1 upon b? Where is my a plus 1 upon b? Yes, ex is equal to a plus 1 upon b. Right, so just opening this up, plus 2a upon b, right? So this gives me 2 upon b square plus 1 upon b square minus 2a upon b, just opening this term, minus 2 upon b square plus 2a upon b. This gets cancelled, this gets cancelled, this gets cancelled, this gets cancelled. I am left with 1 upon b square, right? Therefore, my value of variance, which is ex minus mu whole square, which is ex minus ex minus mu whole square, which is ex minus ex whole square, which is equal to 1 upon b square. Therefore, my sigma square is 1 upon b square, which implies that my sigma is equal to 1 upon b, and my b is greater than 0, right? So I'll ignore the negative one, the negative value. I'll reject that, right? So this is equal to plus minus 1 upon b, and my b is always greater than 0. This is 1 upon b. Let me just erase all of this first. Just focus on this. Sigma is 1 upon b. So yes, so this means that my 1 upon sigma is equal to b. The reciprocal of this is 1 upon b. This implies that my y naught, which is equal to b, is equal to 1 upon sigma. And you can see that we need to show that. We need to show this, that y naught is equal to b is equal to 1 upon sigma. Right, see here. We need to show this. Y naught is equal to b is equal to 1 upon sigma. Moving on. Now, where m and sigma are respectively the mean and the standard deviation, we need to find the, right? So let me just insert some more slides. So m is my mean, right? M is my mean, and A is equal to m minus sigma. Sigma was 1 upon b, right? So what just happened here? Can't seem to understand. What is happening? Why is my slide not being inserted here? Right, so this is right. So we need to show that A is equal to m minus, I'm just checking what we need to show. A is equal to m minus sigma, right? So this is A is equal to, right, m is the mean, m is the mean, m is the mean, mean is Ex. So Ex is equal to m is equal to A plus 1 upon b. Sigma was 1 upon b. This means that A plus 1 upon b minus 1 upon b is, so A is equal to A, right? So we have also proven that minus 1 upon b, this and this gets cancelled, A is equal to A, therefore A is equal to m minus sigma holds, right? So we proved this also. Now we need to find the values of beta 1 and beta 2. Beta 1 and beta 2. For the value of beta 1 is beta 1 was m3 square upon m2 cube. So m2 mu 2 is Ex minus mu whole square. So we already have this, right? We have the value of variance, which is 1 upon b square. We need to find this. So the formula for this was, let me just check the formula. I just noted it down. Let me just check the formula. Where did I write? Yes, here are the formulas. Mu 3 dash minus 3 times mu 2 mu 1 plus 2 mu 1 cube. Three, two, one, 1 cube. 3, 2, 1, 1 cube. Let me just check the formula again. Right, so mu 3 dash minus 3 mu 2 mu 1 dash dash 3 2 1 plus 2 times mu 1 cube. So I have 2 here. So I need to find the value of mu 3 dash. So this is Ex minus 0 whole cube, which is Ex cube. Now one thing that I can do here is that I can write this as Ex cube or Ex cube. Both of these are same, right? So I can write this as Ex minus a plus a whole cube, right? So this can give me Ex minus a so we know that the cube of any term is, right? So if I have any term x plus y cube, any x plus y whole cube, so from binomial theorem we know that this will be 3c0 x cube y0 plus 3c1 x square y1 plus 3c2 x1 y2 plus 3c3 x0 y3, right? And the value of 3c0 is essentially 3 factorial upon 0 factorial upon 3 factorial, which is 1, 3c1 is 3 factorial 1 factorial upon 2 factorial, or the formula for this is nc. For example, I have ncr or ncp here, so this is n factorial upon p factorial upon n minus p factorial, right? So 3c1 is 3 factorial upon 1 factorial and 2 factorial. 3 minus 1 is equal to 2 factorial, right? So this is 3, and 3c2 is again equal to 3, and 3c3 is equal to 1. So so we have all of the coefficients. Now I'll take this first term, this x is this x, or let me just write this as p and q. So this is p and this is q. This is p, this is q. P, q, p, q, p and q, right? So that you don't get confused. So my p here, so my p plus q whole cube, right? So my p is x minus a and my q is a, right? So I have x minus a plus a and the whole cube of this gives me 3c0 is 1, so this gives me 1 into x minus a whole cube a to the power 0 plus, now 3c1 3 times x minus a 2 power a power 1 plus 3c, this is 3c1 and this is 3c2, again 3c2 is also equal to 3, so this gives me x minus a to the power 1 a to the power 2 and ultimately 3c3, which is 1 into x minus a to the power 0 and a to the power 1. So this gives me x minus a cube plus 3 times x minus a square into a plus 3 times x minus a square plus a. So now just putting expectations operator over this, x minus a plus a whole cube or e x minus a plus a whole cube, right? So this gives me, I'm going to the next page, next slide. So this gives me ex minus a plus a whole cube. This gives me e x minus a cube plus 3 times e x minus a square, and I have a here, so a comes outside from the expectations operator, and I have 3 times again ex minus a whole ex minus a to the power 1 and a comes outside. Let me just write a this side, right? So let me just erase this term, erasing this term, this I'm writing this in a good way so that you don't get confused. This is a, this will be a square, so this is a to the power 1 and this will be e x minus a square and plus this is a cube here, right? So this is equal to 3a ex minus a whole square, and this is again a cube here, so a cube comes outside, so this gives me e x minus a cube plus 3a e x minus a square plus 3a square e x minus a plus a cube. Now we need to find now the rth moment was with respect to a was gamma r plus 1 upon b to the power r. Therefore e x minus a to the power 3 is equal to gamma 3 plus 1 4, right? So gamma 4 upon b to the power 3. So gamma 4 is 4 minus 1 factorial, 3 factorial, 3 factorial is 6, right? So 6 upon b cube. So my ex minus a cube is 6 upon b cube, right? So for finding now x minus a plus a cube, or essentially cancelling this term, e x cube is equal to ex minus a cube plus 3a ex minus a square plus 3a square ex minus a plus a cube. Now my ex cube, these terms are same, so ex cube is 6 upon b cube plus 3a ex minus a whole square was 2 upon, wait, let me just check, 2 upon b square. 2 upon b square, 3a square, this was 1 upon b, ex minus a was 1 upon b, yes, 1 upon b, this was 1 upon b, 3a square 1 upon b plus a cube, this will give me ex cube as 6 upon b cube plus 6a upon b square plus 3a square upon b plus a cube, right? So yeah, so we are finding this beta 2. So here I need to find the we found the value of ex cube. So ex cube was 6 upon b cube plus 6a upon b square plus 3a square upon b plus a cube, right? So now we need to find the value of mu2 dash. Mu2 dash is ex minus 0 whole square, which is ex square. So the second moment with respect to the origin, right? So for this I'll be just integrating this over a to infinity x square, fx is e to the power minus bx minus a dx. I can use this to integrate, or finding, and b comes outside, y naught is b, so this is b x square, or I can just use the previous methods that I was using earlier. So for finding e x square, I need to find e x minus a plus a whole square, which is e x minus a plus a and the whole square of this term, e x minus a plus a. So this gives me e x square as e x minus a whole square plus a square plus 2 x minus a into a. This gives me e x, so this e x square is equal to e x minus a whole square plus a square plus 2a e x minus a, right? Now for this value is equal to, so we know that e x minus a to the power r is equal to gamma r plus 1 upon b to the power r, right? This implies that e x minus a square is equal to gamma 2 plus 1 3 upon b to the power 2. This gives us n minus 1 factorial, so this is 2 factorial upon b square. 2 factorial is 2, therefore this is b 2 upon b square, right? So my expected value of e x minus a square is 2 upon b square, right? So finally what I have is e x square is, and e x minus a Ex minus a is just 1 upon b, right? 1 upon b. So gamma r plus 1, this is gamma 2 upon b to the power r. So this is r plus 1. So r is 1. So b 1. Right. So this gives me 2 minus 1 factorial, 1 factorial, 1 factorial is 1 upon b, right? So ex square. So I'm just erasing this. Now I am erasing this. You can see I calculated this in the previous slides, so you can check this out, right? So ex square is ex minus a whole square. Ex minus a whole square was was 2 upon b square. 2 upon b square, right? So now I'll be yes, this is a square plus 2a ex minus a. Ex minus a is 1 upon b, right? Now this is equal to mu 2 dash. We need to find 3 times mu 2 dash mu 1 dash, right? So my second term is 3 times mu 2 dash mu 1 dash. So I'm just finding this term. So this is 3 times mu 2 dash is 2 upon b square plus a square plus 2a upon b, and my mu 1 dash, which is my mean, was a plus 1 upon b. I calculated this earlier, just check it out. So this is 3 into 2, 6a upon b square plus 3a square, 3a cube plus 3a cube, a square and a, 3a cube plus 3a cube plus 6 upon b, 6 upon b and 1 upon b. So 6a square upon b, wait, right? So now just multiplying 2a square upon b and multiplying this by 3 gives me 6a square upon b, right? 6a square upon b. So this makes now multiplying all of this to 1 upon b, right? This gives me 6 upon b cube plus 6 upon b cube plus 6 upon b cube and 3a square upon b, 3a square upon b plus 6a upon b square. Right, so this is our term. Now also we need to find the third term that we need to find was this term, right? We need to find this term also. So mu 1 dash is a plus 1 upon b, so the cube of this and 2 times. So this is, where is my pen? So this term is 2 mu 1 dash cube is 2 times a plus 1 upon b cube, which is 2 a cube plus 1 upon b cube plus 3 times a upon b, a plus 1 upon b. Opening this gives me 2 mu 1 dash cube is 2 times is 2 mu 1 dash cube is 2a cube plus 2 upon b cube plus 6a upon b, 6a square upon b, 6a square upon b plus 6a upon b square, right? So applying this formula, my mu 3 is mu 3 dash minus 3 mu 2 dash mu 1 dash plus 2 times mu 1 dash cube, right? So applying this formula gives me mu 3. So this was mu 3 dash was my mu 3 dash was 6 was my mu 3 dash was, wait, let me just check. So my mu 3 dash was this, right? So it was this, right? This term right here, mu 3 dash. So my mu 3 dash was 6 upon b, 6 upon b cube, 6 upon b cube plus 6a upon b square plus 3a square upon b plus a cube. So now minus of this whole term, right? So this gives me minus 6a upon b square minus 3a cube minus 6a square upon b minus 6 upon b cube minus 3a square upon b minus 6a upon b square. Now adding this whole term, this gives me 2a cube plus 2 upon b cube plus 6a square upon b plus 6a upon b square. Now 6 upon b cube goes from these two terms cancel out. 6a upon b square, 6a upon b square, this term also goes away. 3a square upon b, 3a square upon b, 3a square upon b also goes away. Now a cube and 2a cube, 3a cube and 3a cube goes away. Now I am left with 6a square upon b, 6a square upon b goes away. 6a upon b square, 6 minus 6a upon b square plus 6a upon b square also goes away. So I am left with 2 upon b cube, right? 2 upon b cube. So my beta 1 is mu 3 whole square upon mu 2, which is the variance and the cube of this. So my mu 3 was 2 upon b cube, 2 upon b cube, 2 upon b cube, and the square of this whole term, divided by mu 2. Mu 2 was 1 upon b square and the cube of this, right? My mu 2, my variance was, I just showed you guys, right? My mu 2, I need to go above. So my mu 2, let me just show you my mu 2, right? So my mu 2 was 1 upon b square, right? I just wrote this here. Let me just go above. Here it is, right? Sigma square x minus mu, this was 1 upon b square, right? So my variance or mu 2 dash is 1 upon b square, 1 upon b square and whole cube of this. So this ultimately gives me 4 upon b to the power 6 upon 1 upon b to the power 6. So this and this gets cancelled, I am left with 4. So my beta 1 is 4, right? And we need to show this, that my beta 1 is equal to 4. Let me just show you. Where is my question? I can't seem to find. Wait, I guess I've lost yeah. So here it is. Beta 1 is equal to 4, right? Beta 1 is equal to 4. Let me just, drag this slide downwards. Right, so this was the second step, this was my third step, right? So my beta 1 is 4. Now we need to calculate my beta 2. The formula for my beta 2 is mu 4 upon mu 2 whole square. Let me just check if my formula is correct, the formula that I've written. Let me just check if it's correct, right? So here is my formula. Here is my mu 4 upon mu 2 whole square, right? Yes. So we need to find mu 4. We already have the value of mu 2. So for finding mu 4, is now for finding mu 4 is x minus mu to the power 4, x minus mu to the power 4, or mu 4 is the value, or the formula for mu 4 is, let me just write the formula for mu 4. Yeah, we wrote the formula for mu 4 here. mu 4 dash minus 4 mu 3 dash, right? Four 4 3 1 2 1 square 1 4. So 4 3 1 2 1 1 4 3 1 4 3 1 2 1 1 4 3 1 2 1 1 4 3 1 4 so mu 4, I'm just writing mu 4 here. So mu 4 is 4 3 4 3 1 2 1 and this is 1. This was power 4, right? Let me just see the constant terms. My constant terms were, so this is 4 minus 4 plus 6 minus 4 plus 6 square minus 3 minus 4 6 3 minus 4 6 minus 3 minus 4 6 minus 3 minus 4 6 square minus 3 minus 4 plus 6 square, and this was minus 3, right? 4 6 minus 3, yes. So now we need to find the value of we already have the value of this and this too. So we need to find the value of mu 4 dash. So mu 4 dash is equal to e x to the power 4 or e x minus a plus a to the power 4. Again, this can be written as e x minus a plus a and the whole to the power 4. Now for finding the value of any p plus q, the binomial theorem for finding the value to the power 4 will give me 4c0. My first coefficient will be 4c0, p4 q0 plus 4c1 p q q1 plus 4c2 p square q square plus 4c3 p cube q1 plus 4c4 p4 p0 q4 p0 q4, right? So my coefficients are 4c0 is 1, p4 q0 plus 4c1 is 4, so p3 q1 plus 4c2, 4 factorial upon 2 factorial gives me 4 into 3 upon 2 gives me 6. So 4c2 is 6, 6p square q square plus again 4c3 is 6, 6p, erase this. So this is equal to 6p q cube 1 power 1 over the power of p is 1, power of q is 3 plus 4c4 is again 1, so again 1 into p0 q4, right? So using this I can write the power of ex minus a plus a to the power 4 is, now separating this as p x minus a plus a to the power 4. So my ex4 is equal to e x minus a plus a to the power 4, this is a to the power 4, which gives me x minus which gives me, wait, I'm so sorry. So my e x minus a 4 plus a plus a 1 x minus a cube, so sorry, this gives me e x minus a to the power 4 plus plus 4 times p cube, so x minus a cube plus 6 times x minus a square plus 6 times, wait, this was 4c3, right? So 4c3 is not 6, 4c3 is 4. Just wrote this incorrectly, so this should be 4, right? So this is 4c3 is 4. Yeah, so 4 factorial upon 3 factorial into 1 factorial, so 4 factorial upon 3 factorial is 4 and 1 factorial is 1 in the denominator. So this gives me this gives me x minus a cube plus a to the power 4 and x minus a to the power 0, so that is 1, right? So this gives me e x to the power 4 as e x minus a to the power 4 plus 4 times a e x minus a cube plus 6a square e x minus a square plus 4 times e plus 4a cube e times x minus a cube plus a to the power 4, which gives me ex minus a to the power 4 as gamma 4 plus 1 5 upon b to the power 4 plus 4a gamma r plus 1, so 4 upon b to the power r, so b cube plus 6a square gamma r plus 1, so 3 divided by b square plus 4a cube gamma r plus 1 4 upon b to the power r, so b cube. What am I doing? This is gamma 1, right? This I wrote this incorrectly again. This is the power here is 1, so this is power 1, so this is 4a cube upon gamma 1 gamma 2 r plus 1 2 and b 1. So this is r, so gamma r plus 1 gamma 2 upon b 1 upon b to the power r, so r is 1, right? And a to the power 4, just like this. It's a constant term. So I'm inserting new slides. So this gives me e x to the power 4 as gamma 5 is 4 factorial upon b to the power 4 plus 4a 3 factorial upon b cube plus 6a square plus 6a square 2 factorial upon b square plus 4a cube 1 factorial upon b plus a to the power 4, right? So this gives me e x minus mu to the power 4 or mu 4 as, so I already have the formula for this was mu 4 dash minus 4 times mu 2 dash mu 1 dash plus 6 times mu 3 mu 1 dash plus 6 times mu 2 dash mu 1 dash square. Yes, So we found the value of ex minus mu to the power 4, right? Wait, we found the value of ex to the power 4. So this ex to the power 4 is mu dash 4, right? So now we have all of the values, right? So we have all of the values. So after finding out all of the values, so we have the value of mu 4 dash now. We have the value of mu 3 dash now, I calculated earlier. I have the value of this mu 2 dash, and I have the value of mu 1 dash, right? So I just need to put all of these in this formula, right? Mu 4 is equal to mu 4 dash minus 4 times mu 3 dash mu 1 dash plus 6 times mu 2 dash mu 1 dash square plus minus 3 times mu 1 dash to the power 4. Right, so this was my formula. Right, so this was my formula. Let me check if my formula is right. I need to just check if my formula is right. Yeah, so you have all of the values, so you just need to substitute these values. Wait, where is my slide? So you have all of the values. You have the value of this, and this. Substitute all of the values in this formula. You'll get the value of mu 4. Then put this value in beta 2. Dividing this by mu 2 dash square. Wait, not mu 2 dash, just mu 2, which is the variance. Mu 2 is the variance. So we calculated this also earlier. So substituting all of these values will get you the value 9, right? Now I am not substituting the values, all of these values for you. That's for you to do. I showed you guys, I substituted all of the values and showed you guys the value of beta 1 coming out to be 4, and that's what we had to prove. For beta 2 the calculation will be very lengthy, so I'm just skipping that. You have all of the values, just substitute all of the values in the formula and you'll get the value of beta 2 as 9, right? So thank you for watching this video. I hope you guys like, and if there is any trouble in proving the value of beta 2, let me know in the comments, and I'll upload another video with substituting all of the values in the formula. I hope that it's not a big issue. It's very easy. You have all of the values, just substitute it and you will get the answer. Thank you. I hope you guys like the video. If you like it, subscribe the channel, like the video, share it, and I'll see you in the next video.